Hello and welcome to another day of daily Leetcode challenges. Let's begin our question. Okay, question 109. Convert sorted list to binary search tree. Given a head of a singly linked list where elements are sorted in ascending order, convert it to height balanced binary search tree. Okay, so a binary search tree has the property that current node's left node is less or maybe equal to it, and the current node's right node is higher or bigger than it, larger. So height node's binary tree is a binary tree in which the depth of every node never differs by more than 1. So additionally to a binary search tree, a height balanced one is one where as they said, the depth of the two subtrees are never differed by 1. So the height of the left subtree here would be these two nodes. The height of the right subtree would be these two. The height of this one is 5. The height of this one is 0. So they're off by 1, but this is acceptable because they can never differ by more than 1. Okay, so the example here gives us a linked list of -10, -3, 0, 5, 9. And what happens is the starting node is simply the middle. This is in the case where there's an odd number of nodes. What if there was an even number of nodes? Then either the left or the right would be smaller than the counterpart. And I guess hence is the height balanced, where the left is either one bigger or one smaller than the right. So, okay, I think the way to go about this would be to first identify the collective, the collection of nodes that I'm trying to build. Since they're sorted, I simply can convert it to a array. Let's call array and simply say that while head r append head val, head is equal to head next. Print r. Let's see if this gives us the right array. Okay, and now I'm thinking of developing a recursive function that's going to split the array that I currently have into 3 portions: a left, the current, and the right. So for example here, the left would be a subarray of -10 and -3. The current would be 0. The right would be 5. Then I would set my, what do I have to return? I have to return the root node. Then I set the current node to be equal to tree node with the value 0. Set the left portion of that node to the recursive function, equaling the recursive function given the subarray that is less than the middle and bigger than the, I guess, for the cutoff that is bigger than the left bound and smaller than the mid, and the right being obviously the other one. So let's have a def build that's going to be returning a node, And as a parameter, it's going to be getting a left bound, and a right bound. Okay, now let's have a mid. The mid is going to add left bound plus right bound, right? It's going to add left bound plus right bound divided by 2. Am I doing something wrong? Why is this a different color? Okay. Sorry, why is this a different color? Am I doing something wrong? R is equal to this, while head, I'm going to say head, R append head val, and head equals head dot next, and then I'm going to have a def build left. Okay, weird. I mean, I guess there are right bound. And what this is going to do is first find the mid equaling the left bound plus right bound divided by 2. And then I'm going to choose my values. So I'm going to say that my node is going to be equal to the tree node with the value being the R of mid. And then I'm going to say node right is equal to build with the left bound still being the left bound. No, sorry. Left. It's going to be the left bound, and then this is going to be mid. Okay, now let's think about this. Is this going to be exclusive or inclusive? I think this should be exclusive. And node right build with mid. This is definitely exclusive, and right bound. And finally, return node. Return build with 0. And since this is exclusive, I'm going to say len of R. And this is wrong because I'm getting a recursion depth exceeded. Okay, I am getting this because, why? Because left bound is, so let's say if left bound greater than right bound, then return none. A list index out of range, probably because it is inclusive, and that's it. Sweet. Sweet and simple. I think I'm getting the recursion problems pretty fast now. What is the point of improvement here? The point of improvement, let's think about it before we look at the nodes. So, I actually don't know. Is this again something like, no. Seems like we're really hitting a find the middle element. Are they somehow not utilizing they're avoiding using the linked, I mean the mid data structure that I use for that in my case is the array. Find size. Guys, I think that, let's see, are there any ones here? Nums, head, same thing as me. If left is bigger than right, This is pretty much one-to-one. I wonder why. If left is equal to right, return node. Okay, so this is saving one trip to, this is saving one trip to, mm, let's see if this works. This is saving a trip to the leaf node. So this could be a point of improvement if left bound is equal to right bound, then return node. No, this does not do us well. Just gonna rerun it again. No. Okay, I am going to stick with my previous solution, which was at 70. Yeah. Okay, the most intuitive one is clearly this. Didn't even take that long. The idea is simple. We have a intermediate data structure, but this time is just the array. I don't know how to do it without the intermediate data structure, but what we're going to be doing once we have the array is recursively passing down the left and the right bound, which is going to then tell us what to build the current subtree out of. The current subtree is dictated by the left and the left and the right bounds that are passed to us in the array. How do they do it so that the left and the right bounds are... I mean, I guess I know how to do it. They the the slow starts at the first node, the fast ends at the last node, and then each recursive function, instead of passing down the left and the right bounds, they simply find the middle because the middle is just the length, and then they iterate over the linked list until they get the desired values, the desired middle, and build the tree from that. Let's try this quickly. If this doesn't work, then okay, so slow is equal to 0, fast is equal to also 0, while okay, then I guess I need a node equals head, while node, I'm going to say no, fast plus equals 1, and node equals node dot next. Now I have the fast to me, and now I have the left bound. I guess they could stay there. If left bound is greater than the right bound, then return. We don't need that. The mid, how am I going to find the mid? Well, I can find the mid pretty easily. I guess left bound and right bound are the mid for me. Fast and slow point to that exact thing. And then, yeah, but it doesn't, okay, left bound, right bound. That's all good. Then I get the mid, I get the node, and I pass down, okay, except that the value now is while mid index equals mid while index. I'm going to say, where's my node? Equals to, no, it's not gonna work because what am I gonna, Oh, no, mid works. Node is equal to head. And while index is greater than 0, I'm going to say node equals node.next. So at the end of the day, I will have index minus equals 1. At the end of this while loop, my node should be pointing at, let's call it mid node. My node will be pointing at the value. So my tree node is going to be mid node, val. Node gets created. Let's see. Okay, mid is going to be the mid is still there. And here, I no longer have the length. I have something called fast. Let's see if this works. No, does not work. Let's go with test case, remove that. Let's see if we're at least printing the correct node value. Are we printing val? Printing 0. Oh, very nice. We're printing 0, but then we're printing 3. Is this because should I be doing this? Oh, sweet. Okay, let's reset the test case. So I guess I wasn't that wrong after all. Yeah, so this is oh, I can remove this as well and have yeah, the reason why that's so slow is because I had the print statement there. How do I remove it? Stop. Okay. I removed the print statement. Let's see if ours is faster. I don't think so though, because we're still iterating through the array each time. Okay, so no, not faster. How did they do it faster without using a linked list? They have a slow and a fast, and they're both equal to head. And then prev, and then previous equals to none. While fast and fast dot next. Prev equals slow, slow dot next. Oh, they have a reverse length. Okay, so this is too difficult. Stick to whatever I said at the beginning when it was just an array. I think that should work fine. Where was it? 10 minutes ago. Yeah, this one. All right, so thanks for watching. See you later. Bye.